view. There we are. Now you
Oh,
can
it
see
looks
where we
great.
are. So as I peruse the landscape of the talks here, so a lot of very highly technical, very sophisticated talks about the nuances of cognitech. This is not going to be one of those. This is going to be a more of a higher level business-oriented, business strategic focus of where this technology helps in the healthcare space. And there's a ton of places that it can help, and I think it's got a significant future in this space. So this is what I want to kind of bring to you today as to what we've done with it so far. And the places it can be applied to give you a feel for how big this space is and how rich and vast this space is. So my name is Matt Versaggi. I'm the Senior Director of Artificial Intelligence and Cognitive Technology, as well as a Distinguished Engineer for Optum Tech. One of the divisions in Optum Tech used to be AI engineer for military contractor before then, was an entrepreneur for a while, adjunct professor for a while, did a bunch of stuff. Education nut, 4 degrees, classically trained at AI at the grad level, you know, a bunch of certs, all that kind of stuff. Wear lots of hats. I'm an education SME, senior leader, delivery, mentor, strategist, thought leader, technical SME, that kind of thing. Keeps me busy and it keeps my ADHD down to a minimum. But that's me. What I want to show you in this process, just to give you a flavor, this is going to be different than the presentations you've had. We want to show you healthcare in context, because that matters when we talk about how cognitive tech can apply, specifically not just the SOAR architecture, but cognitive tech in general. We're using the SOAR architecture, but other cognitive tech as well. The context of healthcare matters. It's very significant. And we want to level set on some terms and definitions for the AI as we talk about it. We'll look at a specific use case that we did on the clinical care decision support engine side. Then we'll just dig into the existing healthcare use cases and newer healthcare use cases where cognitive tech, as well as a lot of other AI, can apply, because you may not have this exposure in the trenches of where you're at now. So I wanted to make sure we got that to you. So healthcare in context. The biggest context I can paint for you is that there was this massive movement from fee-for-service to value-based healthcare. Healthcare system's broken. Everyone knows that, and it needs to be fixed. AI as a general tool looks to loom large in that area. Without getting into drain this slide completely, there's so many other aspects of it, but that's the biggest picture right now. Other aspects is it's costly. It consumes a lot of GDP, national resources, local resources, things like that. We can't keep this up. The idea is, where can AI help? How can it shepherd us through from fee-for-service to value-based healthcare? Healthcare is complex. I mean, if you look at this, I struggled to get a picture, an image that would articulate the complexities of healthcare. It's a horribly complex, broken system. And that's just the system. This is the process of all the different aspects of healthcare as you get in there. And we're always going to look at this, we're like, where can AI help? And then where can cognitive tech as part of AI and the general AI space actually help too? So we've got this healthcare ecosystem, and we've got a movement towards a digital healthcare ecosystem. It's a gigantic system. It's a rich domain. The only other domain that's more rich or as rich as this in the AI space and all of its glory is military contracting. So we've got a healthcare system that's moving towards a digital healthcare system, and you've got all of these things that AI and cognitive-based reasoning can parlay, and from EHRs to all of these other capacities, virtual hospitals, patient, care anywhere, that kind of thing. And if that wasn't enough to convince you how big this space is, you've got research and education, home healthcare, payers, which are the insurance companies, pharmacy, employers, private insurance. The financial side is gigantic. If you ever look at how much money goes by here, laboratory stuff, emergency services, screening registers, ambulatory centers, public health, long-term health, and then you've got documents and imaging, hospitals and pharmacy, they all play together. And so it's a rich, rich space for AI and cognitive tech to play. Now, level setting, a few things. We're going to look through a bunch of use cases, and we're going to use these acronyms. We like our acronyms to begin to articulate some of these things. DSML, DL, and RL, data science, machine learning, deep learning, all that. Of course, you've got knowledge rep, robotic process automation, NLU, all of those kinds of intelligent agents, intelligent assistants, which are very different, reasoning systems, and we're going to throw in cognitive tech, which would include the SOAR and many of the cognitive architectures, as well as intelligent agents, things like that. When you see this little head, that is sort of where I'm applying that as well. This is sort of a quick and dirty look at some of the symbols we'll be using to articulate things in the future. Here's a very important slide for articulating a serious issue. If we look at the domains on the horizontal, perception, reasoning, knowledge, planning, communication, there's a few others that probably aren't even listed here. And then we look at the verticals, the actual technologies addressing those things. We've got symbolic, statistical, and sub-symbolic. This is where most of your AI and machine learning exists here. And then sort of the areas that AGI is beginning to play, multi-agent systems are over here. But all of this other areas that's underserved, there are no boxes. There's horribly large pockets and swaths that are underserved. And really what this tells us in our space is that, and if you take a look at just what's yellow here, this is only what we're using. That the portfolio of AI tools that we have to address the incredible complexities in a rich space like the healthcare system is woefully insufficient, and that's a big deal. That's where we need to bring in something like cognitive tech to help bridge those gaps, and that this is a fair argument in that space. Let's look at some healthcare use cases, and I want to be careful of time here. So this is the one use case we used when we began socializing this, and I started talking to John Laird probably a good 2 years ago, I believe, somewhere in that space. We were in our own area, and they wanted to look at decision support capabilities for AI, but they didn't know what would work, and so we articulated that the SOAR architecture would be great for a decision support engine there. And this is just running you through that kind of problem we addressed with that, and we began to socialize and promote. So if you're a nurse practitioner and you take in homeless people off the street, and you look at these individuals, they're enormously complex patients with comorbidities that are extraordinarily complex. They might be living on the street for a while. They may not be malnutritious. They may be drug addicts. They may have coronary and diabetes. They may have emotional problems, may have been raped or beaten, things like that. So the idea is that what do you do first to keep this guy long enough so that you can do what's needed second, third, and fourth? And we call that a care plan. Now we are sitting on some of the largest data sets available anywhere for that. It's called the Omaha system. And these are the kinds of things that we use to articulate the various problems for that. And it's not just medical, it can be social determinants of health, things like that. We rank them according to the Omaha ranking system for knowledge, behavior, and status on a scale of 1 to 5. Now, when you start doing the permutations numbers, the numbers are staggering, and human brains can't process that well when you're given 50 cases like this in a day. By the 50th case, you're just not doing very well. You're going to miss stuff. It's just human nature to do that. So our problem was, hey, could we use this architecture to crunch those numbers and tell us what it is we need to do first, second, third, fourth, just to kind of keep these people alive. And that's effectively what we did in this. So we take a person and we'd give them, we'd understand what the situation was, what the care plan was, crunch all of the information and say, hey, here's what you got to do in ranked order. So the idea was use a cognitive architecture as sort of a decision support system. So if you're familiar with Halo, Cortana, if you've ever played Mass Effect Andromeda, Sam is like that for all you old Iron Man folks. Jarvis is another one for the older Star Trekkies. The computer is another one. And of course, the SOAR decision support system for ours was right in that space as well. And that's what we used it for. Didn't do too much. It was just a POC. It had 20 procedural rules, a small graph of general facts and the semantic side, some working memory, standard stuff that you learn in the 101 space for you guys in this area. But for us, this was kind of a big deal. And it pretty well did the job. As we gave it high, medium, low cases, it was able to crunch the numbers and say, hey, this is what you need to do. And a little bit of here's why. And exactly that's precisely how what happened in that space. So without getting into all the gory details, this is the use case that we use to socialize within our ranks. But let's look at some existing healthcare use cases now that you've seen one. And I would prompt you to look at the richness of this. And I will show you a number of different attributes of these use cases going by to begin to articulate some of that. But I think it's helpful. This is a horribly underserved space. Healthcare is very slow, and they're in dire need of these kinds of wonderful technologies. And we were the first to introduce intelligent agents as well as cognitive architectures in a Fortune 500 healthcare company. And we're just starting to get traction now. So let's look at some of these. We'll take a look at patient personalization, precision medicine, smart hospitals, electronic medical records, and a few other things here as well. These are the existing stuff. It's probably new to you, but there's newer stuff. And we'll show them both to you. So patient personalization, precision medicine. As we can see, the cognitive icon is there. Business people love their icons. But when you take a look at this paradigm from one size fits all to stratified medicine, how do we not take a one size fits all? How do we look at your individual case and prescribe what's necessary for you, from your lifestyle to your genetic profile to your geographic locations and many other things, to give you the right medicine, the right therapies at the right time and at the right cost, because right now we're not. And so this is a big deal. It's a very large use case, and the human value is huge. So we look at what AI is. You'll see these kind of things go over many times here. What kind of AI, decision, data science, machine learning, deep learning, and all of that, as well as cognitive tech, knowledge representation graph databases, knowledge graphs, reasoning engines, and all that kind of stuff. You'll see this change over time. You'll also see a business case and a human value case. The business case is huge in this. Lots of big money associated with making this kind of thing work. And the human value is very large right now too. So that's just patient personalization and precision medicine as a use case. How about smart hospitals? Now, this is a huge deal. This, I think, correlates much closer to the kinds of things you do in this group. Whereas when you're using the SOAR architecture and many other cognitive architectures for autonomous machines, robots and robotics and things like that, what the idea is at smart hospitals, like smart cities and things like that, the larger idea is that the hospital becomes so smart that it monitors the patient, it monitors the environment, it monitors flows of resources going back and forth, where the doctors are, what your schedule is relative to surgery or outpatient cares, and it actually becomes part of the care team because it's gotten so smart. That's the idea. That's the ideal situation, what they want to build. And the business case is absolutely enormous. Just phenomenally enormous. The human value is significant, and this is probably one of the best areas for cognitive tech because it's reasoning over ever-changing context, much like a robot is in the wild. And so of the areas in the future of where this tech could apply, this is an enormous area. Lots of money moving forward, and is absolutely on the radar screen. What else do we have? Electronic medical records. The days of the providers having your medical records and not being able to share them are going away fast. There's billions of dollars being poured into here, and the reasoning process of all this, the shifting of data and all that, provide real fertile grounds for cognitive tech and many, as well as this kind of AI, complex event processing and all that moving forward. Business case is enormous. The human value is significant. I can tell you for sure there's tons of money being spent in this area. You should own your own EHR and be able to walk around with it. Everywhere care, another big deal. The COVID virus has taught us that everywhere care, mobile care, virtual care is a huge deal. It's really pushed that for the forefront because they've shut that down effectively. And look at the numbers, $23 billion market right now. It'll surpass $102 billion by 2022. That's 2 years from now. Look at the huge jump in that market. So cognitive tech looms large in this space as well. Huge business value, human value is significant, gotten pushed really far ahead with the virus situation. Internet medical things will be part of that, so look for that large. Augmented decision making is an enormous space. So I worked for a military contract before I came to Optum, and one of the things that we knew was that AI was never going to pull the trigger. We're never allowing AI to be on the end of a firing button in the military. And AI will never be on the deciding end in the clinical space. They just won't allow it. Now, it'll be in the augmentation end of it, and it can fit in there very well. This is where lots of other technologies can coalesce, can fuse together, as well as the cognitive tech. Huge business case, enormous value for both the doctors, the healthcare professionals, and the people being treated, because the systems take on more of the reasoning process and leave the doctors to do, and this is an acronym in our space, we want the doctors to perform at the top of their license. That means they do doctor stuff. Right now, they're doing data entry. They are exercising at the bottom of their license. They didn't go to med school to input data. Most of what they do now is data entry and data recording. And that's not where we want these guys to be. This is a huge field. Cognitive tech and reasoning capability, as well as all the other AI, loom large in this area. Look to see this become mainstream in a major way. I'm just going to breeze past this, but IoT and ambient computing, we're making smart homes for smart elderly people and retirement homes and healthcare provider facilities, as well as smart cities, things like that. But the reasoning process over the sensory data coming in, as well as the fusion with all these other capabilities, loom large and give us another extraordinarily large business case and a significant value there for the human side. Of course, Internet of Things, that's a big market, and you'll see us cascade into the Internet of Medical Things a little further down the line. But the reasoning process, as intelligence get pushed down to the device level and back up to the server level, the cognitive processes there and reasoning over context is really quite important. Those are the existing stuff. Now, you're not in the healthcare space, so for us, that's kind of old hat. You know, for those who aren't in the healthcare space, you're probably like, wow, that's kind of interesting. It's new, but this is the newer stuff. So we'll look at intelligent assistant simulation, mobile healthcare again. Healthcare operations is huge. Internet of Medical Things, smarter hospitals. We'll look at some graph tech. Behavioral mental health is extraordinarily important. Fraud, waste, and abuse is kind of use cases here. So intelligent assistants, if you're familiar with Cortana from playing Halo, I think everybody's played, I should have at least played a little bit of Halo. It's a great game. But Cortana, that AGI, that augmentative intelligence that can reason over generalized context, is extraordinarily important in the medical space. We don't have it yet. We have that on our radar. That's an extraordinarily important use case that we're going after. I have yet to see a technology approach that has any promise to actually delivering outside of the AGI space. And that's where SOAR and many of the other cognitive architectures play in. So this is an area that if we can crack this nut, that's a multi-billion-dollar industry. Business case is extraordinarily large, fusion of lots of other technologies as well. Human value is extraordinarily significant, but it's a tough nut to crack. Great space to work in. Simulations. So simulations are great. For us, simulating the COVID-19 pandemic epidemic allowed us to do some really interesting things. You'll see some cognitive work in this space as well, because excuse me, the simulations have to be set up and run. So it's a medium value, it's an indirect human value, but it's nonetheless important and it's fascinating. So it's not it's not pocket change by any stretch in our space. But if you look at the numbers, I mean, what did UHG make $500 billion last year or something like that? I mean, the numbers we look at are immense. And so even this is a medium use case, we're talking quite a lot of money. Mobile healthcare, you'll see this moving forward. On-demand healthcare system, personalized treatments, maintaining EHRs, predictive health, drug discovery with clinical evaluations, things like that. This would be a large, massive industry, especially when they fuse in value-based healthcare, blockchain, IoT, and many other things. The cognitive tech is going to be right center in there in many instances for these things. So that's just a revisiting of a use case that's going to do nothing but continually grow. This one's a big one. Healthcare operations. Right now, the healthcare operations is horribly broken. It's horribly inefficient. We are spending 17% of GDP, right? $3.2 trillion. If you run those numbers, those are staggering numbers. And much of that is inefficiency, fraud, waste, and abuse. And that's where AI and cognitive tech can come in and help streamline these things in the digital fashion that will help reduce costs. And we're really just going to have to reinvent it. We shouldn't really, there'll be some optimization of some bad, old, broken stuff, but we just really need to cut it out and recreate it from scratch. So this is a huge, huge, gigantic business case. More money than most people will ever see. And the business, the human value is immense. Internet of medical things is very important too. And this is where I think that cognitive tech is another space in all of its glory, whether it's cognitive architectures or intelligent agents or many of those other technologies emanating from that field can really come into play. Things need to talk to other things so that the infrastructure and architecture can become intelligent, and then that can be part of the care team. And that's a huge movement forward. When that happens, we can open up new markets and services, things like that, and healthcare will never look the same. I see I've got 10 minutes left here. I just want to go into smarter hospitals. This cascades into that as well. The hospitals, again, they're getting to be smarter, and they're getting to be to reduce errors. So this is an important line down here. Medical errors are estimated to be the third leading cause of death behind heart disease and cancer. Now think about that for a second. The medical errors, because medicine's so big and scalable, when you start scaling stuff to hundreds of millions of people, it's easy to fall through the cracks. Personalization is not there. People make mistakes. Doctors make mistakes. And so if the systems can get smarter at monitoring everything and stop humans from killing you, more people survive. So this is a big deal, as well as the business side of it. Graph technology, I'm just going to look at because this is going to be another one of those adjacent technologies that cognitive tech can fit into well, but it's more on the adjacent side, not in the graph itself. But this is going to be a technology in the medical and clinical side that will change healthcare. And we're working with a number of use cases in there. Business case, large human value, significant. If you've not played with graph tech, you really have to do that because it'll change your world. Behavioral health, mental health. There was a talk about this in the portfolio, I think, a little while ago, and I noticed that as I perused it. But what cognitive tech can do to the space, since behavioral health is subjective. When you merge that with the pharmaceuticals and the DSM-5, DSM-6 maybe now, that there's not objective data. Objective data, if you have coronary, we can check your fluids and body fluids and things like that, many other things, and we know like where you are because medical data is objective. But if you go, hey, I've considered suicide again today, that's a subjective thing. Now, the cognitive processing that exists in the SOAR architecture, many other cognitive architectures, when it's combined in an intelligent assistant, can help us diagnose people who need that kind of healthcare. So right now, 30% drop through the general practitioner. They come in, they have mental behavioral health problems, but the GP can't figure it out for many different reasons. But what we surmise from some research is that people are actually willing to talk to a bot more than they are human as a judgmental thing. And so this space could be really benefit. It's horribly underserved, and it's becoming more of an issue. Now, this is the other kicker. Mental health is now the most expensive part of our healthcare system, overtaking coronary concerns. Now, let that sink in for a second. 1 out of every 5 people have some kind of mental health issues. Now, why is a whole different story. But the fact that it is the most expensive part of our entire billion-dollar healthcare system tells you something. That the work that can be done in the cognitive space to help undergird the helping people in this area, particularly through development of intelligent assistance, can really do some great things. Moving right around, I want to talk about fraud. So let me just make this statement. Healthcare fraud, not industrial fraud or anything, just healthcare fraud is $68 billion a year. that the healthcare system gets its pockets picked by organized crime. That is greater than the individual GDP of 12 singleton states. Now, I won't tell you who they are. Vermont's one of them. Uh, but, um, but think about it. You have fraud that is larger than the individual GDP if you ranked it as a state of than 12 states. This is enormous numbers that we're talking here. And so, you know, and it's all here from nursing homes to ambulatory services to all that kind of stuff, medical brokers, medical equipment, laboratory, accidental claims, all of this stuff, fraud's rampant in this, and it's usually organized crime. And so, and they are not using the proper AI in the way they want to, the way they can to help ferret out these cases. The business value is enormous, human value is significant, and I will tell you that there's nothing more satisfying than finding a bad guy using AI and putting them behind bars. So this is a huge space. I'm looking at 5 minutes left here. What's Optum doing right now with Cognitech? I think that's a fair question. So here's what we've done, here's what we've actually done. So I'm the thought leader. So thought leader was championed in 2016 when I came in. We started doing intelligent agents, put it in production, looking at VMware infrastructures for self-healing. So we got that in production. It's working on a very narrowly defined use case and doing a good job. That's what we did in 2016. 2019, we researched SOAR and AGI, and we socialized 5,000 Optum engineers on 3 continents through this process called Dev Days of Ours. Now we have 320,000 employees around the world, so we have a lot. So to get to 5,000 of them might look like a lot, but it's not. But it is engineers, and we're actively socializing that in a very large organization. And we've constructed, which I need to get to John Laird as well for his edification, a pilot program to train engineers in cognitive tech, specifically SOAR. Now we've launched that in May of 2020, basically like 3 weeks ago. So we've realized that we have to train engineers. If you're going to take a technology and put it somewhere, you better start training engineers so they can actually do something. So that's what we did. We have that. And then we've launched a program to do that. We've got engineers on 3 continents, Ireland, US, and India, as of right now, that are being trained. We've procured a small portfolio of healthcare-specific use cases to attack. We're still socializing it. Remember, we're a healthcare organization. We're pretty slow. And we're seeking an internal executive sponsor to help us with that as well. Always an important thing in these big orgs. And with that, we can entertain some questions.
Awesome. Thank you, Matt. We have a few questions. James asks, one of the issues in AI use in military and policing domains is inherent embedded bias in available data sets and human experts. Healthcare as it is already known to have similar biases, viz., women, POC, etc. How can we make sure AI used in healthcare doesn't absorb and maybe even helps alleviate these issues?
All right, perfect. So there's a couple ways to answer that, but the way that we're addressing that, and I'm responsible for the College of AI within Optum Tech, so it's Optum Tech, Optum Teaching Optum, is that we've anticipated this years ago. And so what we do, and we train AI engineers, and we've got AI engineers on 3 continents that go through a very rigorous program. Usually it's years in developing. Every AI engineer has to take an ethics class or ethics classes. I mean, it is imperative in their education in our domain because of who we are and what we can do, and those specific arguments that get levied, that we are training our AI engineers in ethics from the moment they walk in the door, so that when we can literally point to those guys, the classes they took, the date they took it, and when they graduated, and all that, so that we can, our retort to that, our response to that is, yes, we understand that's an issue, and here's how we're training our folks internally to have an awareness at that, both at the outward level, but then also at the developmental level. So when you're making AI, well, if you're making data-oriented, data science, machine learning, deep learning kind of things, to have that in mind, you can do a better job. Now that goes out the door when you're talking about reasoning processes, which is where in the cognitive architecture space, you need to look at that from a different light. That's a whole different ballgame. And depending on the kind of AI you use, that manifests itself, that bias manifests itself in different ways, or that bias issue manifests itself in different ways, and how you begin to solve or at least mitigate for that. Hopefully that answers the question.
Yeah, cool. And then another question I asked, ignoring the question of how challenging it might be to implement, which specific application of cognitive technology would you say would reduce waste or inefficiency the most right now in the broad healthcare domain?
All right, so fraud, waste, and abuse is one of the richest areas. So what we tend to do is we tend to bring in data from many different sources because we're looking for meta patterns. Remember, we're tracking bad guys out there. And there's often times where we know that certain segments of the country have an enormous glut of bad guys, but we can't get rid of them because the laws out there say we still have to maintain those providers so that we can service those areas. So we're in a catch-22. In those cases, you need to just keep monitoring the bad. You know he's bad, but you got to monitor him and his behavior and things like that. So we'll tend to look at lots of different data sources and then ferret out and cross-reference the behavior patterns and the relationships. So that's why we use graph databases quite a bit. If you look at behavioral patterns as singletons, you don't see much, but when you look at them in data science, you see more. But when you look at them in graph databases where the relationships are also held as first and foremost data points, then you see even more. And that perspective of looking at the relationships and how they change gives us ways to track and mitigate these bad actors.
All right, and Roger asks, regarding behavioral mental health problems, has there been any interest in human behavior models and model tracing tutors for diagnosing and helping treat these, e.g. adaptive cognitive training for learning disabilities or psychological challenges?
So in that, I think that we've engaged in a couple of different research studies. One is they're actually working with the DSM and clinicians to develop a reasoning process that's indigenous to Optum based on some of these experts in the space. And in that space, they're actually collecting objective data. Like everything is subjective in the healthcare space, but that's objective data is the first of its kind. So I think that's going to help. The other thing that's going to help, though, that we hope to see is the interface with people of risk that are not indigenous to the general practitioner or initial provider. And through those interactions, if it can be a bot, and this is some of the things we're looking at, I hate using the word bot because it's really kind of a parroting mechanism, so really poor technology, but the intelligent assistance is on the higher end and more educated, intelligent side of that spectrum. The intelligent assistants, if they can be, and it's not a far cry to help train them in some of these diagnostic capabilities through these interfaces, and the interface doesn't matter. Whether it's your mobile phone, whether it's a chatbot interface, intelligent assistant interface, or something like that, but it's connectivity in the back end, where it's pulling that information from, and how well it's diagnosing. The interaction at a strategic level is important, and we hope that can help us lower that 30% of patients who really need care, who are falling through the cracks. If we can lower that percentage and get that down in single digits, we've done some amazing work.
All right, thanks very much, Matt. We are eating into our lunch hour now. People can stick around and ask more questions. We have a few more questions in the chat, but otherwise we will reconvene in 1 hour at 2:15.
All right, I'll hang on if you want to broker the questions, and then when you give me the green light, we can sign off for the day.
Okay, great. So Brian, if you are willing to do it, maybe you could continue to read questions for him.
Certainly.
We'll just sort of run into and people who want to stay, that's great. And I want to say, this has been going great. We have one more session this afternoon, which is our sort of neural section. So all those who've been antsy about not seeing enough neurons, we're going to get those in the last session. And then we will have a session after that, starting at 4, where we will entertain broader discussion topics. And if I can figure out the technology, I'll unleash the attendees so that they can actually talk. All right, so see you back at 2:15. Chris Elias-Smith.
All right. So for people sticking around, and Matt, if you're also able to stick around, we had a few more questions in the chat.
Sure.
Stephen asks, has Optum coordinated with any federal agencies to fund their R&D for AI in healthcare?
No, nope. Well, not yet, because in our space, you got to look at the window of opportunity as it moves forward in time. We're kind of at the back end, and so that means we're kind of slow. We always are connected to government agencies. We have a government, like if you take a look at UHC's portfolio business, there's a number of businesses in there that could be Fortune 500 in and of themselves, but since they roll under the UHC umbrella, we're a Fortune 5. But we do have a business that's government government forwarding or government focused. But I don't think there's much AI in there in the use cases that the government has. But if we're partnering with the government for research in that space, not much yet. We do have some feelers, but in our space, things just go so slow.
And Bob asks, what is your team's perception of cognitive architectures as technology? What is your team's perception of the cost/gap to use these systems effectively in a production context? Any recommendations for specific things this community could do to make future evaluation or adoption decisions easier and to help make the ROI clearer or more evident?
Yep. So the business ROI is clear to us. I mean, you know, when we look at a project, we have to look at its business use case, and the clinical care space, as well as the fraud, the anti-fraud, or you know, the information security space, loom large, and clinical is an enormous space. So I think that area is big. What we need to do is to make the tools more friendly. You know, right now we're dealing with you know, basically a Java app, and that's great for PhDs who can play in that space. But it's not great for software engineers who have to pick up this unique architecture and try to use it. Now, that also necessitates a shift from declarative programming to imperative programming. So you tell the computer what to do on the declarative side all the way down the line. People are steeped in that. That's where we get a lot of our engineers from. But you make that shift to imperative programming, like expert systems and Prolog, things like that. That's a different mindset. And so that's where we had to develop our own training material, because we had to make that shift for engineers from that space over, and we had to do it methodically and pragmatically. Whereas if you're a PhD, you're smart. I mean, you're like a black belt. You can hand somebody a book and go start reading. You can't do that with software engineers. You have to make it more pragmatic and methodical. So the tools that are out there for this architecture could get better, and that would help us on the implementation side. Now, right now it's a Java app, and we can embed that anywhere, and that's not a problem. But the development of competencies, standing up groups of engineers, is the process so that we have pools that can be deployed for various projects across the big enterprise is really critical. You can't do the work without good people. So to make their education process easier would be helpful.
And Shivali also asks, are you open to collaborations with other organizations and academia?
Yeah, actually, we have relationships with Carnegie Mellon University on many different fronts in the AI space. We've got relationships with MIT and a few others. I think that we would want to have relationships with anybody we can, to tell you the truth, when it comes to these cutting edge technologies. We can handle the socialization on the inside. We're pretty good at that, but to be able to have a technology that's continually being upkept, that there's an activity on there that we could use and socialize and try to get engineers start working on those projects is really critical. So we're very open to talking to anybody we can.
And building on this conversation, Stephen asks, this message was not sponsored by StarTech. I see that you are training your own engineers. There are many existing companies specialized to design and maintain AI technologies. What are your motivations for in-house engineering?
That's a simple one. So I started the first global AI machine learning team for Optum. Right, we bought a bunch of PhDs in Ireland, and then we started building some local talent domestically, and then there's some other folks in India that sort of cascaded on. The first time you start building up teams of PhDs, you realize one thing: they're expensive. I don't care where you get them; they're expensive, and they're in demand. And if they're an AI PhD, it's ridiculous the amount of money that these guys can get. So we had a problem. We had to, and these are business problems. These aren't necessarily technical problems, but the business problem is how can we, we need to stand up competencies in a 350,000 employee company to begin handling projects. And so we needed to do that in an efficient and cost-effective way. So we needed to do it fairly cheaply and fairly quickly. So we developed this College of AI, where we've got many pedagogies to help train young computer scientists coming out of the ranks and train them in this space. And so it's been about 2 years maturing, and we're going to add cognitive tech to that moving forward. But that's the impetus for this. We had to stand up our own pools of capable tactical practitioners to actually get the work done. And that was really kind of why we got started.
All right. There are no more questions I see in the chat.
All right.
Thanks very much, Matt. This is a very interesting and engaging talk.
Thank you. It's been a pleasure to help the cause. All right. I guess I'll sign off now. Take care, everyone, and have a great afternoon.
Take care. We'll see people back here at 2:15.
Perfect. Take care.